Hey guys, Algebra 2 honors. Welcome. I felt like after showing you guys the unit circle, I wanted to show you guys just a few more examples. I know you're like, I'm exampled out. So if you want to watch the video and put these into your notes, you can. I just wanted to I feel like, without me being there with you, it's harder for you guys to kind of grasp the examples. So I wanted to show you some of these examples by just both using the unit circle and using reference angles. So kind of like both sides here. So this is going to be 6, 4. And this is basically just going to be like all we're going to be focusing on here is solving trigonometric functions. And again, like you guys can use the unit circle here. You guys can use reference angles. I'm going to show you both methods here. Okay. So we're just going to do, we're going to see how many of these I want to do, but I wrote up a few examples that we can go through, kind of see how long they take us. But let's kind of start. Let's start with our first problem. So we have cotangent of 13 pi over 2 minus secant of 19 pi over 6. So I'm basically putting two problems in as one problem, and I just felt like, this is like more along the lines of what your test questions are going to be like. So I thought that would kind of help you to see these more. Okay, so the first thing I do is I'm actually going to kind of do my thought process over here. But 13 pi over 2, I know that's like way bigger than 2 pi. So I can do two things. So the first thing I need to do, I need to find my coterminal angle. Remember, like if this isn't within 2 pi, you need to first figure out what it is in between 2 pi. And that's using and finding our coterminal angle. Now, what I could do is subtract 2 pi over and over and over until I get something between that, like between 0 and 2 pi. Or, okay, I know when I subtract 2 pi, which would be subtracting 4 pi over 2, I'm still not going to get something that's less than 4 pi over 2. So what about 8 pi? Well, if I subtract 8 pi, I'm still not getting something less. And so then if I subtract 12 pi over 2, which 12 pi over 2 is 6 pi, which is like 3 increments of 2 pi, then it would work. So you can either do that, like that's kind of how I do it and how I think about it. And I get 4 pi over 2. Or like, let's say, and I'm just going to write it here on a separate piece of paper. Like you could do exactly what we did in our head. So subtract 4 pi over 2 and I get 9 pi over 2, which is still not within 0 to 2 pi. So I'd have to subtract 4 pi over 2 again to get 5 pi over 2, which is again more than 2 pi. So I subtract again 2 pi, I get pi over 2, same thing. So whichever way you feel more comfortable with. And this, like, you can't get around not doing this. You still have to know how to do this. So we're going to be looking at pi over 2. Now, pi over 2 is one of our special ones. So this is one that you basically like have to memorize from the unit circle no matter what. So we can go to our unit circle. So I'm going to bring that over. And it is pi over 2 is at 90 degrees. And it's this coordinate, 0, 1. Now it's asking us for cotangent. Cotangent, remember, if tangent is y over x, cotangent is x over y. It's the reciprocal. So all it's going to be is x, my 0 value, over y, my 1 value. So 0 over 1. So you'll often see, like when I'm doing it on my work, I will draw out the coordinate plane and write it here. And then I remind myself, okay, so this point is 0, 1, and this is pi over 2. And I know, okay, cotangent of pi over 2 is going to be x over y. And so x over y is 0 over 1, which 0 over 1 is just 0. So that means I can take 0 and put it here. It's going to be 0. Okay, then we have to move on to secant of 19 pi over 6. 19 pi over 6 is also greater than 2 pi, so I need to again find a coterminal angle. So 19 pi over 6, I'm going to subtract 2 pi. Remember, to be able to subtract, you've got to get a common denominator. So 2 pi is going to be 12 pi over 6, because 12 pi over 6 simplifies to be 2 pi. Okay, so 19 minus 12 gets me 7 pi over 6. So I'm going to first show you guys how I use reference angles for this, and then I'm going to show you how you guys can use it on the unit circle. So I know just by looking at this, first I know my trends of the unit circle. When 7 is 1 more than 6, that tells me it's going to be in quadrant 3. If you didn't pick up on those like tips that I gave you guys in the last video, you can convert this like in your calculator to degrees and then figure it out from there. 7 pi over 6 is going to be converted to 210 degrees, and we know 210 degrees is in quadrant 3. So in quadrant 3, I think about secant and the sign of secant. And remember, it's all like up here, all students take classes. So in quadrant 3, tangent is the only one that's positive. So that means secant is going to be negative. I also know just by looking at this denominator what the reference angle is going to be. When the denominator is 6, the reference angle is going to be 30. So then I can draw a 30, 60, 90 triangle and get my answer here. So 30 degrees, secant is the reciprocal of cosine. So that's going to be the hypotenuse over the adjacent. So that means the secant of 7 pi over 6 is going to be, remember, it's going to be negative hypotenuse over adjacent, 2 over rad 3. You do need to rationalize your denominator. So I'd be multiplying rad 3 over rad 3, top and bottom. So that would mean that secant of 19 pi over 6 is negative 2 rad 3 over 3. And then I bring down my minus sign. So 0, that really doesn't matter, but minus and negative, that becomes positive. And so my final answer is actually just 2 rad 3 over 3. Now, let me show you guys how I would find secant of 7 pi over 6 on the unit circle. So you'd still go through this process. You still need to find your coterminal angle. And then what I would do is go to my unit circle and find 7 pi over 6. So 7 pi over 6 is here, and I think, okay, secant. Secant is the reciprocal of cosine. And cosine, remember, cosine is your x value. So I'm looking at my x value here, negative rad 3 over 2. So the reciprocal of negative rad 3 over 2 is 2 over negative rad 3, which is what we got here. Negative 2 over rad 3, or 2 over negative rad 3. And then you'd still have to rationalize the denominator and get your final answer. So whichever method, like I said, like really both methods have their pros and cons. the unit circle, like you're going to have to memorize the unit circle in honors pre-calc if you want to be able to use the unit circle. You don't have to memorize as much using the reference angles method. However, it's just more work. So like one's a little bit more work, less memorization, and one is less work, more memorization. So it's kind of up to you. Okay, let's do another example here. Okay, so 3 tangent squared negative 5 pi over 6 minus sine 16 pi. Okay, both of these right off the bat and like less than, they're both not between 0 and 2 pi. So if you guys are feeling good from like number 1, you guys can pause me, and honestly throughout this entire thing, pause me at any of these and try them on your own and see if you understand how to do them without me. Because ultimately at the end of the day, you're not going to have me by your side doing these every single time. Okay, so for negative 5 pi over 6, the first thing we have to do, just like we did over here, is find the coterminal angle. Now this is a negative 5 pi over 6. So instead of subtracting 2 pi like we did up here, I'm going to add 2 pi. Now I need to get a common denominator. So to get a common denominator, we multiply top and bottom by 6. So it'd be 12 pi over 6. So negative 5 pi over 6 plus 12 pi over 6. Oh, looks like we're getting the exact same radians as we did in the last one. So 7 pi over 6. Now again, okay, I know we can use kind of the information we know here. We know it's going to be in quadrant 3. And in quadrant 3, all students take classes tangent. Tangent is going to be positive in quadrant 3. And then my reference angle, because the denominator is 6, the reference angle is going to be 30. Sorry, I was saying 6 as I was writing it. So we can draw our special right triangle. And now often, I usually don't draw it every single time. Like I told you guys before, I would write like all my triangles up on top and just use those throughout. But for sake of doing each problem, I'm going to write it out. Okay, so tangent is going to be opposite over adjacent. It's positive. So the tangent of 7 pi over 6 is going to be 1 over 2. Okay. So 1 over 2. Now we can go to our unit circle. I'm going to show you guys how to do this on your unit circle too. So we go to 7 pi over 6. Oh. Okay. Hopefully you caught my mistake. If you haven't caught my mistake, maybe you should go and check your mistake. Check my work and see where my mistake is. This is so fun. But not the brightest person on the bunch. I don't know, in the bunch. I don't know. That's not the adjacent at all. This is the adjacent. I knew something was off. You can always tell when I'm like pausing myself, when I like know something's wrong, when I'm like, huh? And then I think about it. So, okay, so opposite over adjacent is 1 over rad 3. Okay, so I would plug that in, and then I'm going to show you the unit circle in a second. You don't have to rationalize the denominator, because if you notice, we're going to be squaring it. You can. It doesn't matter. Both will get you to the same answer. Okay, so if we go onto our unit circle, 7 pi over 6, tangent is y over x. Now this one sometimes can be a little bit more challenging to see, and I'm going to show you two ways of thinking about it. So one way of thinking about it, I'm just going to kind of use the same scratch paper that I had before. So what it is it's going to be y over x. So negative 1/2 over negative rad 3 over 2. So you guys know when you have a fraction over a fraction, I always like you guys to split it up. And actually, before I even do anything, I would notice the negative and the negative make a positive, so I can get rid of those. And then, okay, once we split it up, we would flip the second one and multiply. And what happens is the denominators cancel, and I'm just left with 1 over rad 3, just like I was on the notes. Now, the way that I do it that's like quicker is because I know the denominators are the same, and I know the denominators are going to cancel out. So I just take the tops when I'm dealing with tangent or cotangent for that matter, and I go negative 1 over negative rad 3, which is what we got here. But we knew this was going to be positive because a negative over a negative. Okay, let's move on to sine of 16 pi. So first thing we need to, again, find our coterminal angle. Now I can keep subtracting 2 pi, but okay, that's going to get me 14 pi, which is still greater than 2 pi. Subtract it again, I get still 12 pi. I can keep going and going and going, but ultimately what I'm going to do is like, I can show you. You know, we're just going to get down to 2 pi. Or I could have subtracted, like 16 pi is an increment of 2 pi. So I knew it was either, like we can think about it as either 2 pi or 0. Those are the same things, because if we think about it, okay, that's one of our special ones on our unit circle that we do have to have memorized. So we look at the point. So that point is here. It's at 0 and 2 pi. Same thing, right? 0 and 360 are the same thing. So this point is 1, 0. And what are we looking at? Sine. So remember sine, and we're going to look at our unit circle like what we did. Sine is my y value. And so my y value here is 0. So it's just going to be minus 0. Okay, so then we can go through and solve the problem. So I'm first going to do my exponents. 1 over rad 3 squared is just going to be 1 over 3. And we don't really need this minus 0 anymore. The 3 and the 3 are going to cancel, and I'm left with just 1 as my final answer. Okay, let's do 2 more and then we'll be done. Okay, so let's look at number 3. So number 3, we're going to do cosecant of 11 pi over 3 plus cotangent of negative 5 pi over 4. Okay, so again, both of these are not between 0 and 2 pi. So we need to start by finding our coterminal angles. Now, I should have said this before, but if you guys are feeling good and confident, then try this one on your own. Don't do it with me. Pause me here. Do what you can do. Okay, now come back, check your work. So first one, 11 pi over 3 is greater than 2 pi. So I'm going to find the coterminal angle. 11 pi over 3, when I subtract 2 pi, that's going to be 6 pi over 3. which gets me 5 pi over 3. Now 5 pi over 3 is 1 less than 2 pi, so that tells me I know it's going to be in quadrant 4. Remember my little tricks of remembering what each radian is in which quadrant. That's how I do it. If you need to rewatch that video, I showed that in the unit circle tricks. Okay, so all students take classes. That tells me that cosine is positive. Sine or cosecant is the reciprocal of sine. So sine is going to be negative and cosecant is also going to be negative. And then my denominator tells me my reference angle. If my denominator is 3, my reference angle is 60 degrees. So I'm going to draw a special right triangle. So cosecant is the reciprocal of sine. So it's hypotenuse over opposite. So cosecant of 5 pi over 3, it's going to be negative 2 over rad 3. I do want to rationalize the denominator here because it's not squared. So I'm going to multiply top and bottom by rad 3 to get me negative 2 rad 3 over 3. Now, if we're using the unit circle, we just go to, you still have to find the coterminal angle like that. You can't, there's no shortcut with that. But we go to 5 pi over 3. Sine, remember, is my y value. So we take, remember, we're finding cosecant, so we just take the reciprocal of negative rad 3 over 2. So it would be just like we found here, negative 2 over rad 3. And then you still have to rationalize the denominator and all that fun stuff. Okay, so then cotangent of negative 5 pi over 4, we then have to find the coterminal angle first. Feel like a broken record, but the more you guys see it, the more comfortable you are with it. So with this, it's negative, so I'm adding 2 pi, so that would be 8 pi over 4, and that gets me 3 pi over 4. So that just tells me that 3 pi over 4 and negative 5 pi over 4 are at the same point on the unit circle. And then I can go from there. So I know that 3 is 1 less than 4, so that tells me it's in quadrant 2. You can also convert it to degrees. If you converted it to degrees, it would be 135. And again, you'd still know it's in quadrant 2. So cotangent, tangent, all students, that means sine is positive. So that tells me that cotangent is going to be negative here. And then my reference angle, if I look at the denominator is 4, so my reference angle is 45 degrees. So I'm going to draw a 45, 45, 90 triangle. Now, I know I always go from this 45. It doesn't matter. You can go from this 45. You'll get the same thing. So cotangent is the opposite, or is the reciprocal of tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So 1 over 1. And so that's going to be plus 1. Okay, now if you were doing this one using your unit circle, so we'd go to 3 pi over 4. And I forgot my sign in there, didn't I? It's a negative, so this should be a negative. So this should be a negative. Sorry about that. So then we'd go to our unit circle and we'd go, okay, so at 3 pi over 4, cotangent, if tangent is y over x, cotangent is going to be x over y. So x over y, negative rad 2 over 2, divided by rad 2 over 2. It's the same thing divided by itself, just with the negative, which is going to simplify to get me negative 1. If you wanted to think about that on a scratch piece of paper, you can. So that would be negative rad 2 over 2 divided by rad 2 over 2. And if you need to see that, like you can flip it and then see that everything cancels, right? Except that negative. And so we're still left with a -1. Okay. So with these, and when you guys get an answer like this, you still, like, what I want you guys to do is not write it like this. I want you guys to write it as one fraction. So what I would do is go, okay, so this needs to have a denominator, and then to combine them, we need to have a common denominator. So my common denominator between 3 and 1 is 3. Multiply top and bottom by 3. So that gets me minus, right? Because the -1, 3/3. Now that I have a common denominator, I can just write this top as 1. I know it seems like extra, but it's preparing you for how you're going to be expected to write them in pre-calc. So that would be your final answer, -2 rad 3 minus 3/3. So there you have it. That's your final answer. Okay, we're going to do one more, and then that will be it for this video. I hope you guys are feeling more comfortable the more examples you see. That's really my whole goal here, is just like the more, practice you guys get, the more you guys see, and the more you understand it, and the more comfortable you're going to be. Because this is such a big part of pre-calc that I just really don't want you guys to go into pre-calc not feeling prepared, because that's really, at the end of the day, that's what's most important, is when we all go back, you're still feeling confident in whatever class you're going into next year. Okay, last example. So 2 sine squared -4 pi over 3. Sometimes you see me write parentheses around it. Sometimes you don't. Often, I'll try and write parentheses when it's a negative, but, it just really depends on my mood, I guess. 11 pi over 2. Okay, so we're going to start with sine of -4 pi over 3. -4 pi over 3, of course. Well, first, before I even say anything, pause it. Try this on your own. See how far you get. See how comfortable you're doing with all of these. Always, 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 as we're going through this, I encourage you guys to just keep pausing, keep trying new problems on your own, and then come back and see, did you get it right? Do you still need my help? Okay, so first, -4 pi over 3, we're going to get a coterminal angle. So what I'm going to do, it's negative, so I'm going to add 2 pi to that. So that means I'm adding 6 pi over 3 to get me 2 pi over 3. Okay, so 2 pi over 3, first thing, I know what quadrant that's in. 2 is 1 less than 3, so that's going to be in quadrant 2. All students will sign is going to be positive in quadrant 1, so we don't have to worry about the sign. And then my reference angle. My reference angle is looking at the denominator, is looking at 3, so it's going to be 60 degrees. And then I'm going to draw my 30, 60, 90 triangle. Okay, we know that sine is the opposite over the hypotenuse, so rad 3 over 2. So I'm just going to kind of put that in here. Now, sine is squared, so we're going to square that whole thing. Now, again, I could go back to my unit circle, double check that I made that's right. So 2 pi over 3, sine is my y value, rad 3 over 2, which is exactly what we got here. Okay, then we need to go to 11 pi over 2. Again, that's not that's greater than 2 pi. So my coterminal angle is the first thing I need to get. So you can keep subtracting by 2 pi, 2 pi, 2 pi, 2 pi. Remember, we're subtracting by 4 pi over 2. So what I'm actually going to subtract by is 8 pi over 2. Because I know I'd be subtracting it more than once. So 11 minus 8 gets me 3 pi over 2, and that's one of my special ones on the unit circle that I need to have memorized. So 3 pi over 2 is at 270. So we know that point is 0, negative 1. And we're looking at tangent. We know tangent is y over x. So negative 1 over 0. Uh-oh. Negative 1 over 0, well, anything over 0 is undefined. So what happens is we're subtracting undefined. Whenever there's an undefined in your problem, then that means the entire thing is undefined. My final answer is undefined. If it wasn't, let's say like you didn't have this part, you would still, okay, this would be 3 over 4, right? Because the exponent goes to top and bottom. And then you'd simplify the 2. So it would actually end up to be 3 over 2. So that is that. That's all the examples we'll do. I hope this helps you guys. Again, please come to after school tutoring. Oh my gosh. Please come to office hours. Remember, office hours are Tuesday, Thursday from 1 to 2. So I hope this helps. I hope you guys have a great day, and I will talk to you guys soon. Bye.